Hola, my name is David from the group Prince Tardy, and this is my song on the operations on sets. Enjoy!
Universal set is really the most important set aspect. It's the superset, contains all the sets. It's the superset. Universal set, it is called. Complement of a set is an operation. It's the elements in the uniset that aren't in the set. It's the complement of intersection is another operation used in sets. It's the elements, same in two more sets, usually A and B. It's called the intersection. Union is the operation where two or more sets combine. It's the superset, contains both elements of the sets given. The operation union. Difference is the operation hardly used in sets. It's the elements in the first given, not in the second set. It's called the difference of sets. This is a song about the different operation sets. There's the complement, union, intersect, or maybe difference. And it's all about sets.
Yay! Adios! Thank you for watching.
Up next, Mr. RD Tagle.
So, we will talk about rational algebraic expressions. What is it, by the way? It is an operation of polynomials. Uses the common operations, the four basic operations, which are addition, multiplication, division, and subtraction. It is solved by using your factoring, expanding skills, etc. Now, I will teach you how to solve rational algebraic expressions. Now, how will you solve this overly complicated rational algebraic expression? You may want to simplify the first term first. Now simplify the bottom denominator, which is 3x squared minus 2x minus 8. Then, with your skills in factoring, you will get 3x plus 4 times x minus 2. And then, rewrite your equation with the factor polynomial under it, which is 9x plus 2 over 3x plus 4 times x minus 2. Then the second term. Use the same technique from the first term. Factor the denominator, then you write it. So, factoring it, it will result to 3x plus 4 times x minus 1. Then you write this, and it will become 7 over 3x plus 4 times x minus 1. You might want to use the technique wherein you combine 3x plus 4 times x minus 2 and 3x times plus 4 times x minus 1, making it will become 3x plus 4 times x minus 2 times x minus 1, and it will be your LCM. Now, since 3x plus 4 times x minus 2 times x minus 1 is your denominator, you will get 9x plus 2, and because the denominator is 3x squared minus 2x minus 8, when you get 3x plus 4 times x minus 2, it will equate to that. So the remaining is x minus 1. Then you'll get the second term, 7, then multiply it to x minus 2, because 3x plus 4 times x minus 1 is equal to 3x squared plus x minus 4, which is the denominator of 7. Solving the first equation that we got, we will get 9x squared minus 7x minus 2 plus 7x minus 14 all over 3x plus 4 times x minus 2 times x minus 1. Simplifying the numerator, you will get 9x squared minus 16. This will be equals to 3x plus 4 times 3x minus 4. Canceling the both 3x plus 4 out, you will now get 3x minus 4 all over x minus 2 times x minus 1. Solving RAEs is easy at all. It's not hard. It seems one when you don't know how to solve it. Now that you know how to solve it, it seems easier.
Let's all welcome PDSoriano!
Imagine you're a crazy friend wreaking havoc in the town, and the only way to solve the mystery is to decipher the code of the ancient mystery. Except it's a math equation. Well, let's examine the two clues you have, a crazy math code and a half-open vault. Let's start off with the most obvious thing to solve. Looking at it, you see again those irritating letters that always appear everywhere. What is x anyway? X is a variable, one which can change its value depending on the given equation, except it's an overused one, so it's kinda the ultimate king of multiple-phase nightmare in the world of math. Well, anyway, we need to find the value of x. Looking back at our equation, let's start off with the best thing to start things with: long exponents. Let's analyze this long string of numbers, x the base and the rest the exponent. Well, apparently there exists a convention which we call the order of operations, which by far is claimed to have solved every problem in the universe. The first letter of the acronym means parenthesis, and it kinda tells us that we start from the innermost grouping going out. Doing some arithmetic, we'll have an answer of x to the 0. Wait, what? Well, apparently we exist in a universe where such is equals to 1. So we just kinda apply to this one. Now our equation is easier to see. The next dilemma is negative exponents. Well, it's pretty much the same thing, except we get the reciprocal of the base. So after distributing the exponents, we do the same technique to the multiplier. Going to the next two letters, meaning multiply and divide, we'll clarify something here. Students always do is multiply, then divide, giving us an answer of 1/6 in this example, which is totally wrong, at least with the PEMDAS believers. The correct way to do it is to multiply and divide simultaneously from left to right, giving us the correct answer of 3/2. Going back to the equation, we will kind of rewrite this like so. Then after factoring out x, we cancel out 16x, giving us this. After distributing the negative factor, we get this and do some arithmetic. When that side looks crazy impossible to solve, go to the other side. There's apparently a thing called special products, which are special. Our example is dots or difference of two squares. And you'll say, wait, what? And actually realize that 529 is actually a square. Here's some kind of formula for dots, and you could substitute the second variable to get our answer. Writing it down, we could cancel it, and we're left with this thing, which at the first glance looks like the answer is this, but actually going back and actually transposing them, we'll get x equals 0. Probably correct, because there's no other number to substitute it with, right? Except we could go back to this, and instead of canceling, do the actual multiplication. It'll give us this and a thing called factorizing. You'll notice that both terms has an even coefficient and has x, which means their GCF is 2x, giving us this. Notice that one of the two factors must actually be 0 to get a product of 0. Substituting, first factor equals 0 gives us the previous answer, and the second factor equals 0 gives us negative 23. Substitute it, and we find that it's actually true. Going back to the cipher,
Click like if you liked the video, comment for any suggestions, and subscribe to our channel.